There are various ways of solving these two equations, or there are various ways of solving simultaneous equations. One is you can plot them and find out where they cross. You can substitute one for the other, so you could substitute in here for y, which would be, that would be x plus 1, so there's the y, equals 1 minus 2x, and then work out x. You could substitute for x instead, which I'm not going to do, it's a bit lengthier and I haven't got the brain power. Or one way I quite like is to add them or subtract them. So let's write them. Okay, what this is minus equals y equals minus 2x plus 1, and the other one is y equals plus x plus 1. And I'm going to subtract this one from this one. Y minus y is 0 equals minus 2x minus x is minus 3x. 1 minus 1 is 0. Whoa! Excuse me. In other words, minus 3x equals 0, but so divide this by minus 3 and we get x equals 0. Then we put this x equals 0 into one or other of the equations to get the value of y. Of course we need both values. So this would give us, so x equals 0, y equals 1. So something that I think is very interesting is, I'm going to choose two equations now and see what happens when we solve them simultaneously. One is y equals minus x. Quite simple. And the other one is y equals 1 over x. Right? So what do you think? So that would mean that 1 over x equals minus x. Yeah? And that would mean dividing through, multiplying both sides by x, that means that 1 equals minus x squared. multiplying through by minus 1, we get minus 1 equals x squared. Taking the square roots, we get the square root of minus 1 equals x. So we've got this square root of minus 1. What do you think of that then? Now, if we plot these two, you'll see we've got this square root of a negative number. Where is that? Right, so I'm going to plot them. I'm going to draw them. I'm not going to plot them properly. I'm going to draw them. So y equals minus x, that's this line here going through there, through 0, at that angle. 1 over x happens to be, this funny thing. This is called the hyperbolic. Right. And on the negative side, it does this. This up here, it goes nearer and nearer the axis, but actually never gets there. And same here, it gets nearer and nearer the axis and never gets there. So although I've taken these two simultaneously, they're never equal. There's no simultaneous point between these. So there are equations that are not simultaneous. You can't just assume that they all will do that. And this is a particularly interesting one. Generally, for your, well, a trivial way of, a kind of trivial pair of equations that I should have asked you this, what kind of linear equations are never simultaneous? Here's one. What kind of other linear equations, what other kind of linear equations are never simultaneous with this? They're the ones that are parallel. Anything parallel are not simultaneous.